Aviation was once the exclusive domain of commercial and military pilots. Not anymore. Today, many amateurs get their pilot's license and take to the skies in light aircraft. Not for a job, but for the sheer pleasure of flying. To construct the body of these light aircraft, they start with two types of cloth. One woven from glass fibers, fiberglass, the other from carbon fibers. Carbon is a chemical element that's stronger than steel. Both materials go through a laminating machine that coats them with an epoxy resin. To begin forming the various parts that make up the body, workers lay strips of the laminated fabric into molds. The engineering plans dictate the precise positioning of the strips, which is critical for strength and durability. They lay in carbon fiber cloth where they need to have extra strength without additional weight. Areas such as this, the passenger compartment of the cockpit. To make the fuselage, they sandwich a foam core about 10 millimeters thick between two layers of the fiberglass cloth. The foam also insulates against heat, cold, and noise. Workers coat the edges and joints with resin, filling any voids. Once all the fabric is in the mold, it's time to vacuum bag it. First, they cover everything with a layer of perforated plastic. Then with a breather cloth, which looks like a white wool blanket. Then comes another layer of plastic. They attach a vacuum to suck out all the air. The excess resin exits through the tiny holes in the plastic and soaks into the breather cloth. Now that the mold is airtight, it can begin to cure. They put it into an oven at 40 degrees Celsius for 8 hours. Once the molds come out of the oven, workers install the internal structure. Then, using the same epoxy resin they used earlier to laminate the fiberglass and carbon fiber fabrics, they bond the tail's upper and lower shells together. They do the same with the wings. The parts are left to cure overnight. The next day, they finally come out of the molds. Next stop, the trim shop. Workers remove the excess fiberglass and cut out the windows. The parts go back for a final curing. The oven is 80 degrees Celsius, twice as hot as last time. 18 hours later, out they come for painting. Workers sand the parts and coat them with an epoxy primer first. The finish coat is a polyurethane which resists weathering. Meanwhile, other workers assemble and test various components, such as the electrical system. A computer guides a machine to cut all the metal parts, such as the instrument panel. The cutting machine doesn't have a blade, but rather a sand and water jet that's powerful enough to cut through metal. A certified aircraft welder prepares the engine mount, the base that will hold the engine in place. It's made of high-grade carbon steel. At the final assembly stage, workers install the engine and other previously assembled components into the fuselage. Workers position the wiring and plumbing, then hook them up. They screw on the wingtips, which already have their navigational lights. An avionics technician powers up the airplane for the first time to function test everything. The final inspection takes place where it really counts, in flight.